Okay, we're going to do truth tables for arguments, section 6.4. What I'm going to do is at the beginning of section 6.4 in your text, they're going to give you steps that you do to set up an argument and get it into a truth table and then tell you what to do after that. So here's what I'm going to do. I don't have the steps written down in this handout. I'm going to come down here with an example that the book had, and we'll do the truth table. Then I'm going to pop back up and we'll go over what you do after you have the truth table set up. The truth table, how you set it up, is just a little bit different than what you've been used to, because you just add some slashes in there, okay? So if you were going to go to the first part of 6.4 in your textbook, section 6.4, doesn't matter what edition, you're going to have this up there. It's going to say, truth tables provide the standard technique for testing the validity of arguments in propositional logic. To construct a truth table for an argument, follow these steps. So I'm going to read the steps that's in the book, and we're going to go employ these steps when we're looking at this argument here, okay? That I'm circling right here. Okay. So first step, symbolize the argument using letters to represent the simple propositions. Okay, so it says if juvenile killers are as responsible for their crimes as adults, then execution is a justifiable punishment. Juvenile killers are not as responsible for their crimes as adults, therefore execution is not a justifiable punishment. So if we were going to use J for juvenile killers, that makes sense, are as responsible for their crimes as adults, then execution is a justifiable punishment. So execution, justifiable punishment, we will use E. That makes sense, right? Here it says juvenile killers are not as responsible for their crimes as adults. If J is they are as responsible, then them juvenile killers are not, we would call that not J, right? Therefore, execution is not a justifiable punishment. That would be not E, since we've designated E to mean execution is a justifiable punishment. So if we read this, in the therefore, there's our conclusion indicator word. After therefore, you have your conclusion. And if juvenile killers are as responsible for their crimes as adults, then here's premise 1, and then premise 2 is juvenile killers are not as responsible. So if we were going to write this out, the first premise here would be this one. All right? After examining that, premise 1 would be if J, then E, right? Premise 2 would be juvenile killers are not as responsible for their crimes as adults. That would be not J. Therefore, execution is not a justifiable punishment. That would be not E. Okay? So you take an ordinary argument here. You assign, you symbolize this, assign the propositions, each proposition, assign it a letter. We've done that. We've got it down to an argument form, a skeleton. So we've done the first step at the beginning of section 7.4. Remember, after we get the truth table laid out, we'll go back up to the first part of the handout here. I'll skip back up, and then we'll talk about some of the stuff up there that you need to know, because once you look at a truth table for an argument, you're looking for a specific line, and whether, depending on whether you find it or not, is going to tell you whether this argument that you've drawn up a truth table for is valid or not by using that truth table. Okay, so right now we're just in the process of getting the truth table going. So at the beginning of section 6.4, we have symbolized the arguments using letters to represent the simple propositions. Write out the symbolized argument, placing a single slash, this is step 2, between the premises and a double slash between the last premise and the conclusion. So what we want to do is let's write this out in a linear fashion. And they say between premises, draw a slash. But when you're at your last premise, between the last premise and the conclusion, do a double slash. So here our first premise is if J, then E. It says go ahead and draw a slash. Okay? The second premise is not J. And then what it says is if that's your last premise, use a double slash before you get to the conclusion, and the conclusion is not E. All right? So let me read step 2 again, and just listen and pay attention here. Write out, so we have a symbolized argument, write out the symbolized argument, and in a linear way, place a single slash between the premises and a double slash between the last premise and the conclusion. So we have a single slash between two premises, and right here this is really premise 1, and this here is premise 2. Let's kind of just make sure we just separate that out. Okay. All right, and here's one thing you need to know. Let's say you just had an argument that had, if B, both B and R, therefore D. Okay, so if it would be both B and R, you would immediately go to a double slash. Okay, so you wouldn't need a single slash here. If you just have one premise, it says the last premise, and if you only have one premise, it is the last premise. The last premise, you always do a double slash between the last premise and the conclusion. So any arguments with only one premise, you would just use the double slash, right? And you would not use a single slash because you only have one premise. It wouldn't be needed. Okay? So that's a little aside, but you're going to get some arguments with only one premise, and that might confuse you. Okay, so here's our argument in English propositions. We've assigned letters to represent the propositions, and we've symbolized the argument, and we get it into a linear line here. And then what we do now is let's just do a truth table. Okay, how many distinct alphabet letters? How many lines? Is 2 to the n. So there's 2 distinct alphabet letters. 2 to the 2. It's 4 lines divided by 2 equals 2. That means you go to the very first distinct simple component or proposition, and you don't switch to false until after 2 lines. So true, true, false, false. So we're just doing a truth table here, and go ahead and duplicate it. In a sense, ignore the slashes right now and treat the whole thing as a compound proposition. Duplicate it, so true, there's J, right? True, false, false. Then you divide that 2 by 2, and that equals 1. This means you switch every other line. So E is true, false, true, false. Go ahead and duplicate it. There's E again. So under E, true, false, true, false. Okay, and then we'll switch colors here. Then we still have work to do. So if E is true, false, not E is going to be false, true. It's just the opposite, right? False, true. If E is true, not E is false, okay? Same here with J. If J is true, false, not J is false, false, true, true. And notice I'm writing the final column under the operator, okay? It's being written under the tilde. This column is being filled out underneath the tilde. Here we're going to fill this out underneath the main operator there. So if we have true, true for a horseshoe, a conditional, that's true. True, false is false. False, true is true. And false, false is true. And why don't we just outline these in a square or rectangle. Okay, there is our truth table for this argument, right? So we've got that. Now let's skip back up and go through the rest of the handout here, okay? And this is even in your book, okay? You draw a truth table, step 3, for the symbolized argument, as if it were a proposition broken into parts, outlining the columns representing the premises and the conclusion. Okay, and we've done that here. Then you're to look for a certain line, and that's what I want to talk about, is step 4. Okay, in your book, step 4, I'm going to slow down and explain this. Okay, so at the beginning of section 7.4, it says to look for a line in which all the premises are true and the conclusion is false. If such a line exists, the argument is invalid. It is not valid. Okay, why is this? Well, we're hearkening back to section 1.4, and I have the textbook here. If I go to section 1.4, do you remember the definition of a valid deductive argument? A valid deductive argument is an argument in which it is impossible for the conclusion to be false given that the premises are true. And this makes sense. Validity has to do with a good skeleton, that the good skeleton, the logical inferences flow and they connect, and there's no break in the logical chain, right? Validity has to do with a good logical thread. It doesn't really have to do with the content. So what that is saying there is, if you have a valid deductive argument with a good skeleton, if you then have the premises that are true, there's no way true premises with a good valid skeleton are ever going to deliver you a false conclusion. So if you look at this truth table and you see a line where you have true premises and on the same row the conclusion is false, you know that the structure of the argument, the skeleton, is a bad one, because it's showing the truth table. Remember, it exhausts all possibilities. You're being shown with this argument it is possible for the premises to be true and the conclusion to be false. A good skeleton will never ever, if the skeleton is healthy, good logical inference, there's no break in the logical inference chain, a good skeleton with true premises, you're never going to have going over, your eyes panning over to the conclusion. You're never ever going to see a row with true premises delivering a false premise. If you do, you know you have a bad skeleton. Okay, so I'm going to kind of repeat this as I read the handout. Remember, the definition of a valid deductive argument in section 1.4 is one where it is not possible for the premises to be true and the conclusion false. Now, a truth table exhausts all combinations of truth values that the components of an argument may have. Therefore, if no line exists in which the premises are true and the conclusion is false, then it is not possible for the premises to be true and the conclusion false, in which case the argument is valid. Okay, remember, since it exhausts all possibilities, if you don't find a line with true premises and a false conclusion, then it's not there. That means it's never going to be there because you've exhausted all the possibilities. And it says with this argument and its skeleton, it's impossible with true premises to have a false conclusion, because if it was possible, you'd find a particular row with true premises and a false conclusion, right? Okay. Conversely, if there is a single line on which the premises are true and the conclusion is false, then it is possible for the premises to be true and the conclusion false, and the argument is invalid. Right? A good skeleton, you're never going to have true premises ever giving you a false conclusion. But if you see a row with true premises, and remember, if you have an argument with just one premise, then that row, if you see a row where the premise is true, the one premise, and the conclusion is false, Likewise, we have an invalid argument, because good skeletons, valid arguments, will never have true premises, premise or premises, ever giving you a false conclusion. So if you don't see that line, it's valid. If you do see that line, it tells you it's invalid. Bad skeleton. Only bad skeletons can have true premises and deliver you a false conclusion. Okay, I'm probably starting to get a little too redundant, but hopefully the redundancy helps you. So here's the rule for testing arguments by truth tables. You have an argument, there it is, argument right there. You have a truth table for it. Here's what you do after your truth table is all set up. And let's go back down to that truth table. Here's the rule. If there is a line, actually let's scoot that down. So here's the rule. The rules for testing arguments by truth tables. If there is no line on which all the premises are true and the conclusion false, the argument is valid if you can't find this kind of line. True premises, false conclusion. Can't find it? Valid argument. Okay? However, if there is at least one line, you just got to find one on which all the premises are true and the conclusion false, the argument is invalid. So all you got to do is find a row with premise or premises true, false conclusion, invalid argument for the reasons just specified above. Okay, so let's go here and look down at our truth table for this argument, and what we're doing is we're looking for a line with true premises. In this case, there's more than one, true premises and a false conclusion. And here's a little tip. Just examine the rows where the conclusion is false. Okay? Remember, so you're trying to find a line with true premises and a false conclusion. So you don't have to pay attention to this row here. You can almost ignore it because it's got a true conclusion. And ignore this row, it's got a true conclusion. Here we have a false conclusion and a false conclusion. Just look at these rows. So here, let's look at this one. Are the premises both true? No, we're okay. What about this one? False. Are the premises both true? Yes, they are. So here we have found a row where the premises are true, delivering a false conclusion. This tells us the skeleton is bad, so this is going to be invalid. Okay? Just because we found that row in row 3. So row 3, we have true premises and a false conclusion. And so this is what you will do with any argument you're given. Symbolize it, put it in a linear fashion, put a slash between premises, put a double slash between the last premise and the conclusion, or if you only have one premise, you're going to go right to double slash. For one premise, double slash conclusion. Do the truth table, treat it like an ordinary compound proposition, and then see if you have a row with true premises and a false conclusion, and to save time, only examine the rows where the conclusion is already false. Ignore the rows where the conclusion is true, and you're looking for that line, true premises, false conclusion, it's invalid. But if you can't find any line with true premise or premises, false conclusion, it's valid. Okay, and that's how you work on all the examples, and this is how you use truth tables for an argument. Do the truth table, and if you can't find that particular line, true premises, false conclusion, it's a valid argument. If you do find the line, it is invalid. Kind of nifty. Okay, we'll move on to section 6.5 on the next video clip.